Okay, so for this week, I went through and I put my drivetrain back together on my new robot. So I haven't done any more with the steering. It's where it was. And the drivetrain, I just simply bolted the motors back on so the belts are hooked up, and it all put it all together, and it does seem to move. So I'll pull up an image here of show up it. I'll pull up a live image so you can see it. So it looks like this now. And again, maybe you can see my cursor, maybe not. These are the two Pitman motors on the back. And this is the stuff about, I don't know, 6 or 7 meetings ago, I held up the pieces for the back end here and said, this is what the pieces are going to be. And I simply bolted them onto this thing. And on the right hand side of the picture, you can see there's a wheel. You can see there's a tooth belt that connects the wheel to the motor, and these motors have 65-to-1 gearboxes on them, and technically they're either 19.1 or 24-volt motors. I haven't bothered to look. That'll come up in a moment here when you see one of them doesn't turn as well as the other. So anyway, that's put together, and then on top there's one of the Citron single channel motor driver boards. And if we had a little better view, you can see I put those wire ferrules on the wires again. So the two power wires have the 18 gauge ferrules crimped on, and the two red wires from the motors have the I think it's 22 gauge. It's either 22 or 20. It's either 20 or 22 gauge ferrules crimped on that. And again, they seem to work fairly well on what I'm trying to do here. And then the other two wires, the two black wires from the motor, are just twisted together right here. And when I first did this, I thought, well, I need to put the motors in series. So I thought, well, if I put the black to the red and hook up the other ones, that should work. And it turns out, no, one of them was going forwards, one was going backwards. And that had me totally baffled for about 2 hours. And I sat down and watched TV, and I finally realized, oh, when you put batteries in series, you do hook up the plus to the minus, and so forth. So the way I hooked it up, yeah, so both motors were turning the same direction, but since one faces one way and one faces the other, I need one of them to go backwards from the other. So I finally realized, oh, let me hook the two black wires together and then power the two red wires. And that does indeed work. So what I'll do now is I will fire up it's got the drill battery on top. I'll hook the tab, plug the tab in. And I don't know if you can see it, but the green light on the board just came on. And this has the two push buttons. If I push the one button for forward, it's kind of going forward. If I push the backwards, so you can see the one on the right hand side of the picture is turning better than the one on the left hand side. Now let's see if I can get over there. I got a cord in the way. Okay, let me try this again. So what I'm going to do is I'm going to get the thing turning, and then I'll grab the one that's turning well, which I think was this one. And when I do, you'll see the other one will speed up. So when for some reason, the one motor is more efficient than the other. And I think it's because it could be the belt's too tight on this one over here. Let's see if I grab it and slow it down. Then you'll see the other motor speeds up. And now I've got this one completely stopped that I'm holding on to. And if I let go of it, then it'll start turning again. The other one will come to a stop. And if I grab this one and stop it and pull it backwards, the other motor speeds up when I do that. And that's exactly what a differential is doing. And I think even if I were to, here, I haven't tried this before. Let's try this and take this off. Yeah, maybe I don't have to unplug it, but I will. I'll unplug this. If I just grab this and turn it, so with no power applied at all, you can see as I turn this one forward, the other one's turning backwards. And again, that's what a differential is supposed to do. So I think I've come to the conclusion that yes, what I want to do is put the two motors in series to make this work. So what you do is I put it out, since they're in series, I just give it some amount of power from this driver board. Right now, it just got the two push buttons, and it goes probably full forwards or full backwards. I'm not sure if it's full or a percentage because it's got a little 555 timer on there. So they might have it backed off somewhat. And right now, I don't care. I just wanted the motors to move.
Is the reason that you did them in series so that one can spin faster than the other if you're turning?
Yeah, that was the whole point of doing that. And my reasoning was I could either put them in series or put them in parallel, because just a standard DC motor, if it's you put power on it, it's going to spin a certain speed at no load. And if you put your hand on it and slow it down, it will that motor will actually slow down some amount, but you're only going to be able to slow it down like maybe 10%, if even that much. And then likewise, if you try to push it faster, it can go maybe 10% faster before it starts fighting you. And I decided that that may or may not work. It's going to have a limited turn rate anyway, because the Ackermann steering, when you turn, that I haven't calculated how fast the back wheels have to turn to do that, but I decided that in parallel, it's probably not going to work well. And I thought in series that should work, and I've hooked it up, and that does appear to work that way. So, and then say right now, as I showed it, the one side was turning slower than the other one. I think as soon as I put it down on the floor, then they have to turn at whatever speed they want to turn. So I think it'll just work itself out. The other issue, the one that turns slow, I think maybe the belt is too tight on it. I've got some again, I don't know if you can see my cursor, but right there's an adjustment screw there, an adjustment screw there. They just simply I tighten it down, which pushes the axle away from the motor. That tightens up the belt. So I think it was this one that was turning slow, and the belt is pretty tight if I press on it, and I can just back that screw off, except that it's a normal screw that I got to put a screwdriver on, and there's a motor in the way, so I can't do that. So if I tear it all apart, pull that screw out and put a say an 832 screw with a hex head on it, then I might be able to come in with a wrench from the side to be able to adjust those. So that's just something else I have to tear it apart one of these days and do that. But I think once I put it on the floor, so I've got the weight of the vehicle on it, I think it'll work just fine the way it is without doing this extra, say, belt tensioning or whatever. So that's basically where I'm at with it right now. And it's really just a matter of I might, instead of putting the board here, I might put it down inside the box here, because I realized I thought that'd be a real handy place to put it for testing. But now if I try to flip it over on its back while that board's in the way, I'm going to smash that board. So I might put that down inside and start putting stuff in there. And then coming off the back here is the encoder wires. And this particular motor already had wires on it with these 10th inch setter connectors on. So I just have to solder some wires on a perf board so I can plug those in. So I've got the two encoders on the motors, and then I can now control the power. And on the Cytron board up here, it's got the 3 pins coming off. It's got a ground pin and a PWM and a direction pin on that thing. So it's just a matter, I got to connect that to a microcontroller to be able to control the amount of power going to both motors. And then if I want, I can take the speed off the 2 encoders. If I want to do feedback to get, no, I'm at exactly the right speed, I could do that. So that's kind of where I'm at with that right now. I thought I had one more thing I was going to say about this. I don't. So let me go back, switch cameras back here. Any more questions out while I got the picture up?
Yeah, well, I was just curious, had you considered, since you're going to have a microprocessor, did you consider doing the dual channel?
The dual, what, you mean drive both motors separately?
Yeah.
I haven't considered that, because I think that just causes more grief on trying to figure out, well, how much power do you put to each motor then to make it do that. So as people point out, and I at one point Sohin on the meeting said, yeah, you could get these really fancy motor driver boards that will run your motors exactly the speed you tell them, and then look at your steering and calculate how fast the wheel should go. And he had all this elaborate plan to do that. And that's when I said, it's just too elaborate. You should just be able to hook them in series and make it work. And then if I go search online, there's people doing like research papers, and they're going down the same line. They're saying, well, we're going to look at the steering and calculate how fast the 2 back wheels should go. And then they're apply either the power, or if it's a fancy controller that you give it a speed and it turns that speed, then you have to get that right. So now you may have those fighting against the natural physics of the thing. So I think I'm probably just going to leave it the way it is, unless I come up with a reason to abandon that and go with something else.
Okay. It was the only reason I was thinking that was because you're having the problem with the wheel, with that left wheel. And if you had them independent, then your PID could take care of keeping them as much in sync as they could.
That is true, yes. But for the moment, no, I don't plan to do that unless I have enough problems that it won't work. So speaking of, since I'm going to have a microcontroller, let me go back. So speaking of a microcontroller, now I'm back to the point, what do I want to put on it? So this is the board. This is the eval board from ST Micro. This is the same one that's on SAMI 2 right now. And I was thinking about it, and basically I could just put it on directly because all I have to do is delete one of the quadrature inputs, because it had a quadrature encoder on both back wheels, and it had one on the main drive motor. And right now I just have the two on the two back wheels. Technically the encoder's on the motors, but essentially one is for the left wheel and one's for the right wheel. So I just have to get rid of one quadrature input, and I'm still driving on that one. It also had one single drive motor, so I have a PWM and direction to drive that, and that's exactly what I need on this. And then to run the steering on the front, they both have the same RC servo. So basically, as I look at it, everything I could possibly put this right on there and run it as is, but I will probably recreate something. So I have, and the point is, if I go with this board, which is the ST Micro board, I can do up to 4 channels of quadrature decode with this chip. And then I've got this board. So this is the ST Micro board, and this is the one that Juan found when he found out you can't buy this ST Micro board anymore. He found this other board on either eBay or Amazon. It's got, essentially, you can get it with the same chip or one that's got half the amount of RAM or half the amount of flash in it, I think. And it doesn't have a lot of extra crap on the board like the eval board has. So it has the processor. So it has the processor chip here. It's got a voltage regulator here, and this over here is some kind of a flash chip. It's like a 1 megabyte flash chip or something. It's either I2C or SPI. They just stuck on for the heck of it. And there's a little chip here. I don't know what this one is, but there's some other chip on the board, and then it's got an SD flash card. The mini, is it a mini or micro? I guess that would be, I think those are micro SD flash. And as is, it doesn't do them any good unless I put code to the board here to read that and talk to that, but it's just a matter of dropping in code to do that. So essentially this is the same, and for size comparison, there's the size difference between those two. And I don't need a lot of stuff on the green board. One other advantage of the green board is it's got, let's see, this one, that it's got an extra microcontroller on the board right there that talks to this USB port, and that allows you to download the board, and I can single step and breakpoint and all that stuff. So it's got this whole section here as a debugger at this end of the board, and then it's got the main processor. It just runs out the IO pins, and it's got push buttons and LEDs and a fancy audio generator chip and a bunch of other stuff that you would expect on an eval board. And since this one doesn't have the debugger section, then you get these little modules like this. You buy those on eBay for like $3 or something, and it's all that debugger stuff with a microcontroller, and you just plug it into the board over here. So basically I can get the same functionality by putting those two things together. And then once I get it programmed, I should be able to unplug this and run without that. And then the other option is of the stuff I have on hand and of the ST Micro. This is that blue pill board. I should get a camera that works better, but anyway, so there's the blue pill board. So compare that one to the big board. It's like this. So the blue pill it's about the size of an Arduino Nano, but it's got more pins. It's got maybe, I don't know, another 10 extra pins or something. And then comparing that one to this board, like the board that Juan had, this one's got about like 100 IO pins out where you can get to them, and brings out, it's a fairly modern processor. So it's got all the, the latest, hottest, I just say the latest, hottest peripherals, but now they've gone to a Cortex M7, which is a better one. That's what's on the Teensy 4.0 and Teensy 4.1. And that's one that runs at 600 megahertz. And is just phenomenal. But you know, I don't need most of that stuff. Just this one here is an old crappy, like a Cortex M1 processor, but it still has the quadrature decode that I need. So technically I could probably put this on to do all the low level control. And then it's got the USB port, so I can run that out to my whatever my ROS computer is to talk to the thing. So I'm kind of at that point where I have to go through and figure out, you know, what processor do I want to pick. And since I've been using ST Micro, I could use one of these 3 boards. And this one again, you have to add the external debugger to come on, focus. Like in the theaters, you say focus, focus. There. Anyway, you buy this module, it just plugs in your USB and gives you the debug capability. Now technically at least on the blue pill board, if you put the correct bootloader on this thing, then you can plug in your USB cable here and hook it up to your Arduino IDE, and write your code and click the button that says download. And theoretically, it should download and run just like you're using an Arduino Nano. And I think I tried that one time, but I've never gone ahead to find out, well, does it work in real life? So that would be an interesting thing to do, is load this board up and make it work like an Arduino, and then see what libraries are available. Because I'm going to need quadrature decode. I'm going to need something to run the PWM for the main motor, the PWM for the RC servo, which is 2 different types of things. And the original board, the original SAMI 2 had a CAN interface. I just simply had to solder a CAN peripheral chip on the board, on my main board, and connect it to the processor. And then my remote control receiver was CAN, but I could throw out the CAN completely and go to my smaller or my remote control receiver board. I originally bought the Adafruit board that was a processor and a LoRa radio all on one board, but it did not have the CAN peripheral because it was using an old enough. Last week we were talking about the difference between a SAM 21 and a SAM 51. Well, the board I had, they got a SAM 21 on it, and it did not have the built-in CAN peripheral. So what I ended up doing was I bought a Feather LoRa radio from Adafruit, and then I bought an adapter that adapts Feather to Teensy. So I've hooked those 2 together, and then I took a Teensy 3.2 and hooked up to that. So I've got instead of buying having a cheap solution, I've got a radio that was like, I don't know, at least $10, and then adapter board was $6, and a Teensy is like $22 or something. But that one had the built-in CAN peripheral. So I've got this stack of boards that will talk. It talks LoRa radio to my remote control unit that I carry around, and then the other side's got the CAN interface. So I've got a little CAN bus that's about 3 inches long that connects those 2 together. And as I've said in past meetings, the only reason I put CAN on it is because I was trying to duplicate an industrial remote control we had at work, and that's why I built it that way. So anyway, I could just put the cheaper board on that's the all-in-one boards with LoRa radio and some random ARM processor, and just connect it together with a UART or I2C or whatever. And if I really wanted to, I could just hook the LoRa radio. Say if I'm going to use this board, just wire the LoRa radio up to this board, and that way I get rid of an extra processor, and that may or may not be what I want to do. So that's some stuff to think about there. And before I went with the ST Micro stuff, this is a TI eval board that I bought one time. I went to a seminar and I got the thing and played with it. And it's the same concept where here you got the main processor that comes out to a bunch of IO pins. And then over here is an extra processor. So again, this whole end of the board is the debug section. So it's got its own USB port coming in here. And then it's got the processor that talks to the debug pins on here and does all the fancy stuff. And then it's got so the main processor then also has a USB port here. And that's the same thing on all the, like say on this one, it's got the 2 at one end of the board. It's got let's see, at this end of the board, it's got the USB port for the debugging section here. At the other end of the board, it's got a USB port that talks to the main chip. So it's the same concept. So normally, the only time you talk to the debuggers, you're actually writing code and trying to debug code, and then otherwise you unplug that, and then if you want, you can put code that'll talk to the the other USB port if you want to make it work, say, closer to an Arduino. And the only one I know will do that is the blue pill board. So if I use this board and it's got the debugger on it, then theoretically I can write the code, or theoretically on this one I can put the correct bootloader onto this and treat it like an Arduino and just pull the debugger out, not use it at all at that point. But people have actually got this to work, so I think it'd be easier to do that than try to get one of these other boards to look like an Arduino. It could be if I look, somebody else say, oh yeah, here you just load this bootloader on it and it works just like an Arduino. But that's more of a journey to go down to figure out how to get this stuff to work. So that's again, as I say, I'm back to the point where now I'm gonna have to pick a microcontroller to make this thing run. So that's kind of where I'm at right now, and that's why I was thinking about these other processor boards. Other things that have come up. As I say, I lost my head and bought the newer version of the giant RC servo. This is something like ASM 303 something, and this is the one that the feedback pot is on the back of the board where you can't get to it. So you have to, if you want the feedback, you have to pull the board off, solder the wire on, put it back together. And I found the one that's the latest version. It's something like an ASMC 04B, I think is the latest version. And I thought that one's got the pot right here on top of the board where you can get to it. But as I looked at it more, it turns out over on these pins here, they've got a set of pins that just says output, or it says position feedback or something on it. So I think they've just brought the wires from the pot out to a pin, and then they've got a second pin that's ground. So if you, by using that, you don't even have to solder any wires on the board. You just plug into the little, it's got this row of jumper pins there on the end. And some of them, they put the little jumper blocks on so you can select different options. And then it's got the 3 input pins for PWM in, or you can move one of these jumpers and say, I want to run on voltage. So it's got the 3 pins. So you put a voltage into the pin. So you can either control the position by a voltage 0 to 5 volts, or you can give it a standard RC pulses to control the position of it. And if I'm hoping that the newer board, it's going to be a nice tight control over the position feedback. If I hook it up to my little RC, what do you call it, RC tester, and turn the knob, if I turn the knob, I expect it to follow that exactly. And I was just noticing on the one I've got right now that if I turn it, I could turn it, I don't know, several degrees before the motor would even start up. So I want to see if the new one works any better than that, which gets back to my concept about I could, just to verify if these things are working, I could just take this and hook up to all my different servos. And as I turn it, just turning this and watching the shaft, you get a good idea. Is it tracking exactly, or do I have some of my deadband there? So I thought, well, that's the quickest way, hook it up to my new one, then hook it up to my older ones and see how well that works. And then otherwise, if I go back to, as I've said several times now, if I get like an Arduino Nano and use that as the controller and have it load the whatever library it takes to talk to an RC servo to control the position, and then take the feedback wire from the RC servo, feed that to an analog pin, then I can get the so by plugging that into a USB cable and going to my Arduino, I can run the serial plotter, and I can watch, it plots like an oscilloscope. So you got these 2 lines coming across, you move this one, then this one should come up and follow it. You move it down here, it should come down and follow it. And I should be able to see visually if it's doing that. And I thought, well, I like the idea of this, but I have no way to get the number out of it. So if I just put an extra pot on my Arduino Nano, that now gives me a knob I can turn and just feed that into the A to D input. So now I've got everything there, and I can still get both the input position and output position and plot it if I want to, or just simply, play with it and watch it on the screen to see what it's doing. So that's something I might get to, since I think that servo is supposed to show up on Saturday. And then the other thing, it come back to people having problems with electrical noise. And I remember I was going through the ROS agriculture meetings, and Matt was saying, well, he went through and rewired his whole thing. So he separated all of his battery power, his high power stuff and his logic level stuff. He separated all those out, but he still had problems. But the problem is, you got something like, say, this, and it's got the big power wires coming in here, and it's got the logic stuff here, and internally on the board, those two are tied together. So no matter what you do to separate things, you're still tying your battery ground to your logic ground through this module. And you have the same problem whether you have this or you have the here's the here's the Super 200 servo, which is what Matt was running. This is what Al has on his transmission, and it's got the same concept where you've got the high power motor ground here, and then is tied to the logic ground here. And I was thinking you have one other case of that. So basically on my system right now, I've got one of these servos for my steering, and then I've got that Cytron power driver board that's going to drive the main motors. And so the Cytron board has the same problem. It's tying the two grounds together. So I was looking at optoisolators, and I went through Amazon, and people sell you all kinds of different optoisolators, and nobody seems to get the concept. So it seems kind of worthless to buy a 4-channel board when they've got all the channels tied together. And they give you the option, you can put on a jumper and tie your grounds together there if you want to, because they're trying to sell those things as a logic level translator. So you can buy it, says, oh, it'll convert 3.3 volts in to say 12 volts or 24 volts out. And they just do that by changing the resistor values on the board. So their thing is, when you buy them, as diligent as people are on Amazon and eBay, that they're going to say, here it is, and here's the documentation. But when you get it, that's not what it is anyway. And I thought, well, what I really want, I want to totally isolate the thing. And if you buy a single channel optoisolator board, then they will be separated. They might put a jumper where if you want to, you can connect the grounds together, but you could do that. And you can buy a single board for $12, or you can buy 3 of the same board for $12, again, depending who you're buying from. And I finally decided, well, I'm just going to buy the chip that they're using on that. So I bought a package of 50 for like $7 or something. So those are supposed to show up on Saturday also. So I can try those. And again, there's a lot of debate on how fast these things are. Will they give you a clean square wave? That a lot of people are saying it'll run at 80 kHz. And somebody else that bought a board says, well, how do I crisp up the output? And he says, if I run a 4 kHz signal through it, it's more rounded than the way I want. So the guy wrote back, says, oh, you just have to change the pull-up resistor value to give it a stiffer pull-up, and you get a better signal out of it. So I don't remember if the spec sheet says 80 kHz or where they came up with that number. So that there's some debate there as, if you just hook it up and run it, will it work or not? And then I also ran across the old one that they use on the MIDI interface. On MIDI, they would use a 6N138 chip, and MIDI runs at 31.25 kbaud. And if they can get a clean enough square wave to run MIDI at 30 kHz, then I'm thinking it'll run at 20 kHz or 10 kHz or 5 kHz. And I probably have some of those in a box. I don't know where they're at. And rather than buying one of everything right now, I thought I'd just get these ones that are really cheap, and all the Chinese people are using them, and just see if they work out or not. So you could put that between, say, any of your, whether it's your RC servo or your power driver boards, you can opto-isolate the signals going into those, and that will completely isolate your two grounds on the system. So that's something else to experiment with. So when those get up, when I get those, I'll hook them up and try various resistor values and various frequencies, and see how cleanly I can get a square wave to go through those optoisolators. And
I remember when I had created my own motor control board, I had gone through that exercise of optically isolating all of the inputs, and found out that the PWM was not fast enough. The optical isolator I had was not fast enough and was definitely giving a rounded. And so I had to jury rig a faster one, which is part of the reason why I decided to scrap that board.
Yeah, when I was going through a robot shop of horrors, I was trying to figure out when you started the Twin City Robotics, and one of the meetings says, here's Terry looking at his slow optoisolator. So we've got that documented somewhere. I don't know if we had the waveform. I think maybe Alan was looking at the oscilloscope, and the comment that Terry had slow optoisolators. So yeah, that's one of the first times I realized that optoisolators are not fast enough for a lot of things you want to do. So then you have to pick and choose to find the ones that will do the job on that.
I think if I remember right, I ended up going with a optical isolator that was then had a Schmidt trigger on it.
Yeah, if you buy the ones that say they're communication grade or something like that, because it'll say it's for communications, they'll run at 1 megabit per second. And sure enough, you put a square wave into it and a square wave comes out to it. And they worked as great. I don't remember. Somewhere I've got some of those laying around, and somewhere I would be able to find the part number. But right now, this is what turned up as, just a cheap part that everybody's using. They're like 16 cents a piece or something. So I thought I'd give this a shot just to see what I can actually get out of the thing. So I think that's pretty much what I have to say at this point. And oh, the other thing was when I was going through Robot Shop of Horrors and found Terry's first entry, it says Terry's robot. And here, that might have been the first meeting he showed up, and he had his robot, and he had some motors from Axeman that had some kind of a plastic encoder disc on the back of them, and he had, I think, a belt drive to his wheels. And then throughout the years, then he switched took those motors off, and he's got the Pitman motors like I've got on mine, and he's got a wheel stuck right on the end of that. So I realized that going back through all this old stuff that I've documented a long time ago, there is valuable information in there. Unfortunately, the pictures are really small and you can't make them any bigger, and there's not a whole lot of description on stuff, but I can go through that, and then I can go back to the Twin City Robotics meetings, and then we've got starting like 1999, we started documenting meetings, so you can see when people come and go, and see when they start on a robot, and several weeks later, here's a better robot, and then 3 years later, it gets bigger and better. And I've got several of my robots documented that way, where I can go through and look at the evolution of this stuff. Kind of like what I'm doing right now in these meetings, where I said I was thinking about this, and I said, okay, here's my green robot on the floor. I could take the wheels off that. And then another meeting said I did take the wheels off, and I held them up, and then said, well, here's my RC servo. So now I'm up to the point now where either last meeting or the one before, I showed my complete steering, show that it actually does move back and forth. Now I showed the wheels turning in the back, and hopefully the motors in the series will do the job. So hopefully by next week, maybe by next week, I'll set up my little servo tester thing that I keep talking about. Maybe I'll try to get that set up and say, here's my opinion of the 3 different versions of the giant servo, and then compare that to the Super Servo 200, and maybe hook up just a couple of standard servos just to see if those really do what they're supposed to do. So I might have that for next week, and maybe I will be far enough to choose a processor for my new robot. So we'll see what happens on that. So I think that's all I've got to say, unless there's any questions on any of that stuff I just spewed about there.
Where did you buy your new servo and your opto isolators?
They're both just random companies on Amazon. And in fact, again, looking at pricing on these things, you can buy the servo just like this for like $65. And what you really need, the thing that goes on here, and most people don't sell it with that, but I ran across one that said you can get the servo, you can get this adapter plate for $57. So if you consider that, they'll sell you the adapter plate for like $10 to $13. So that means that the servo that's the newer version of this it cost me like $47 by doing it that way. So it's just a matter of you pull it up and look at everybody selling it and try to figure out, do they know what they're talking about? The biggest thing is, what are they going to charge you for it, and what do you get with it? So that's how I got the RC servo. I just went to Amazon, and I think the part number is something like AMS 04B, I think is what, something like that. AMSC, something, that's the basic part number. Or if you just search for giant RC servo or whatever, it'll bring up ones that you have to dig through and figure out which ones you actually want. So that's how I got the RC servo. And then the optoisolators, I went through both Amazon and eBay, typing in optoisolators. They got all these different boards you can buy. And I kept looking at them thinking, well, but they're not really isolating things. You look at people's comments and say, well, they're not really opto-isolating anything. So I finally decided, well, screw that. I'll just go out and buy the bare opto-isolator to try it. So it's just, again, on Amazon, I put in the part number of that. It was something like an EL 817 or 917, something like that. Again, there's lots of people selling those. And a lot of these things, you can buy a chip for $5, or you can buy 50 for $6, and then anywhere in between on what they're selling there. Now, another problem is the official chip is made by Sharp. So it's SHARP, and they hold up his other ones, and you look at the top, and it says SRAP. It says SRARP. So it's, you know, obviously not the original part that they're selling, but you know, that's another reason why I'm thinking, can I just buy, you know, random parts that I know are not actually from Sharp and get them to work? So that'll be another interesting thing to try on that. So to answer your original question, I just do a lot of digging. I come up with a thought and then go to my two search engines, which is Amazon and eBay, and say, show me what you got. And if on a good day, you can find something that does exactly what you want and get it for half the price what somebody else is selling it for. And the other thing was, it's apparently coming from somewhere in the US, because they said it's going to show up in like 4 or 5 days or something, as opposed to order from somebody in China, which is obviously going to be cheaper, but it might take you 2 weeks. And the way the world has evolved, I haven't ordered anything from China lately, so I don't know if there's going to be problems getting parts anymore that way. So that's kind of how I did that.
Terry, anything to share?
Nothing that I can really show, but I did run across a new YouTube channel by the Articulated Robotics. He's got a bunch of a series on building a robot and integrating it with ROS from the beginning, and adding LiDAR and adding both a digital camera and a distance camera to his mobile robot. And it's since I don't have ROS loaded yet, I haven't been able to see how accurate, but because it's relatively recent, I know he's using ROS 2, which is what I think I'm gonna go with.
I think you'll find some of his older stuff was ROS 1, and then he's switching over to ROS 2 on that. As far as the question, has anybody seen it? Well, Al was just quoting this guy in some of the last few meetings, something he ran into, and it. The thing I noticed was he's one of these guys that will just take tutorials from somewhere else and present them, but it's handy to have somebody actually sit there and go through it and say, do this and this and this. And as long as you don't realize that same information exists somewhere else, you think he's a real genius. But still, yeah, he's got a really good channel and he presents the stuff really well. So that is a good thing, a good place to look.
And he does provide references. Like he says, I'm not going to talk about PID right now, but I've included some references to it. So I just kind of 6 out of the 15 or so, and I'm finding it insightful in some cases, and seeing what the capabilities are in ROS that I wasn't really aware of, and trying to get the new vocabulary and understand that. But as far as what I've accomplished, I've added the itsy bitsy chip that SAM D51. It only has one quadrature decoder, and since I've got the 2 motors, I couldn't find any way of duplicating that within the having 2 completely hardware-based quadrature decoders. So I'm just to keep it simpler, I'm going with the interrupt-based. And since it runs at 120 and can be overclocked up to 200, I haven't seen an issue with it yet, but I haven't added the PID yet. I've added a 1/6 of a, or 1/10 of a second timer interrupt to calculate RPM and meters per second for each wheel, because that I need that in order to be able to drive the PID, so that I can say, okay, I want to go this velocity and be able to have that number to compare to. But when I tried incorporating that into my bigger program, it didn't seem to want to calculate. I think it's the getting my volatiles right so that they can share between the interrupt and the main loop. Goals for this coming week is to, once I get that RPM and meters per second, then add a motor-based PID, so I can have a PID for each of the motors individually, and then one for the entire robot. I also got some plastic, so I can make some angle brackets for the battery mounts, so that I'll be able to slide them in and out. And then once I've got those, I'll wire up the fuses and the switches, so I can get everything actually sitting on the robot rather than just laying on the robot.
It's fun that I think you mixed software engineering, electrical engineering, and mechanical engineering all in the same sentence. That is robotics.
Yep. So I'm done. Al, take it away.
Well, I don't have much to show other than a continued. Let's see. This is the RViz. I mean, and still, I mean, so the tractor is, simulated here, and if I give it a 2D nav go straight down, which I'll do here in a second, this is command velocity, echoing command velocity in this linear X. I'm still trying to figure out why that isn't the number that I'm expecting. So I want the tractor to go, at maximum about 1.8 meters per second. If I give it a goal that's, just straight ahead, I mean, the variation in this linear X is really, I mean, I don't know, plot juggler, but you can see those numbers vary all over the place. I mean, there was even a negative number that comes by there. So if I go to the two places where I thought I had it up here, sorry. Come on. There's a couple of places in the why is that being so slow? Yeah, maybe because simulation is running. The two, maybe I put it on my real machine. Yeah, that's what I did. So there's this YAML file, tab local planner, and there's this YAML file, base local planner. What I have up on GitHub is the old, the original code, but basically I've changed these velocity things to 1.8, and I've been playing around with these theta limits again, trying to see what the variation is. And in the tab local planner YAML file, there's also references to velocity, which at some point, I'm assuming then there's the handshake between the local planner and the TEB planner on that. But what strikes me as odd at the moment is, number one, I'm not getting to anything like 1.8 on command velocity. And the variation is also surprising, that it's not, just calculating a value and expecting you to be there. So it's like recalculating a lot. I don't know if there's a way to control that or not. So those are some of the struggles that I'm fighting through at the moment. Well, fighting through is I'm not fighting through, I'm perplexed.
So have you gone through they have various TEB local planner tutorials, and some of those they might specifically talk about how do you control the speed. They might give you more of a rundown there of, change this number and it does certain things for you. So if you just, go to the ROS wiki and search for what I found, if you go to the ROS wiki and search for anything, the search function doesn't seem to work anymore. And I don't know if it's my computer or my browsers or whatever. So if you just go to Google and put in ROS TEB planner tutorials, and then it'll point you back to the ROS wiki to get in there. And there's several different ones where people are going through these things. And I haven't really, I haven't tried to track this down, this stuff you're talking about right now. So I don't know for sure how useful that will be.
Yeah, I mean, it's probably worth going back through it. I have done probably 3 of those, but none of them are Ackermann. And I don't know what the difference would be, but yeah, back to Terry's comment about the articulated robotics guy. One of the reasons why I like his videos is you think he's actually trying to help people. Some of the tutorials of I think they're trying to show you how smart they are, and they don't really anyway, that's just a political comment, I guess.
I think that guy actually does know what he's talking about, but it's back to the same concept where anything you find on YouTube, they're usually just saying, oh, it does this and this and this. And if you go look at the tutorial in ROS wiki, he's just taking you through the same steps, but it's a lot of times they put in very valuable comments like it says to do this, but it really affects it like this. So he does seem to be a very smart guy, and he does seem to know what he's doing. So I'm not trying to put anybody off from watching any of these tutorials, but that's my take on that.
So that's where I'm at, trying to find somebody who's actually done this is my challenge.
So back to the point where several meetings ago I said, yeah, you've got the section on the local planner, and then you got the section on the TEB local planner. And you said, well, maybe those two are fighting each other. And as you said that, it occurs to me, I believe if you say use the TEB local planner, it simply totally replaces the standard local planner. So it could be that none of those parameters for this, the base, the standard local planner, it could be none of that stuff is being used at all. So just keep that in mind.
So
the TEB
more
planner,
if you will, because one of the reasons that I consolidated this, let me get to my folder view so you can see it a little bit better. Where might it be? So one of the reasons why I got everything into one folder is to be able to rule out something that I didn't know was impacting it. And so these are the only YAML files in this package. And so it is I think still a good thought to say, are these two things fighting? Because they definitely, one they definitely think they have control over the velocity because they put stuff in the TEB local planner. There's a velocity comments, and in the base local planner, there's obviously velocity related stuff too. Tell me more.
I'm thinking the base local planner may not be used at all, because if you say use TEB planner, I think it replaces the base local planner. But that's just a thought. That's just something to keep in mind, that as you go through this stuff, that may be the case.
Is it possible to echo out what that parameter is, the value, and be able to set them at two different values to be able to verify which one's actually getting used?
I don't think they're going to change dynamically, but when you first start up, when you say run your launch file, it lists all the parameters at that point, and you should have one namespace that will say TEB local planner, or it'll say base local planner and have all your values listed there. And then down a little further, it's going to say TEB local planner parameters, and should have all those listed. And my first thought was, well, the names may conflict between the two, but if the name, say, like for instance, says max velocity X is set at 4.0 on whatever you're looking at here, and so that one also might have a max velocity X, but I think they're going to be under separate namespaces. So I don't think, if you're specifying something for the base local planner with a velocity of 1.8, I think it'll just simply be ignored, but I don't know. Now, since they are parameters, I don't think while the thing's running, those parameters are changing. It's typically something you'll set up ahead of time. It's like putting a constant into your code. So when you go to run the thing, you say, here's the values I want you to put out there and make available. And back to your immediate question, that there is some way you can say, dump out the values of the parameter server. And, while it's running, I think you can actually see, and you could check to see if they're, as Terry says, maybe that you got two conflicting values that keep going back and forth. That certainly would be something that could happen. But I think since they're parameters, I don't think they're going to conflict on that.
I was thinking more of, if you think it's being driven by one file and you're changing it, but you're not seeing any changes in the results, could it be a different value that's actually being used for whatever reason, whether the base overrides the other one, or?
Yeah. So the point is, as you said, make them different. So make in one file, put it, say 1 meter per second there, and put it, say, at 2 meters per second, and run it and see what it's doing. And then swap the two values and go run it again and see if you can tell which one is actually affecting your speed. If either one is, it could be there's something else funny going on here.
Yeah, that's a clever debugging suggestion. What's perplexing is I've got both of them set at a maximum velocity of 1.8. Pretty much I've got both of them set the same. And it doesn't get up to anywhere close to that speed, but it's still, I think, a clever debugging.
So is that running right now?
Yeah, I can give it a 2D nav call.
Okay, go pull up another window and fire up your RQT reconfigure, which should show you your actual parameters, and you can change them on the fly at that point. So it'll show you which ones are there, and then you can change the values, assuming that TEB planner was written for RQT reconfigure. So you might be able to type in RQT underbar reconfigure, and it might come up. Otherwise, you might have to just run RQT and then prod at it until you can get it to work. Just try that and see what it does. Okay, so another way, just type RQT and see if it comes up. It'll just give you a blank. If it works, it'll just bring up a blank window, and then you have to say select plugins or something and find it that way. And if that doesn't work, then you have to do like a ROS run, probably RQT or something. Aha. So up there, I think it was where it says plugins. And it's called introspection or something. Yeah, introspection.
Under configuration, there was dynamic.
Yeah, that's what you want right there. Dynamic reconfigure. And you can make that window bigger if that'll help. Looks like I brought up another window underneath too. Oh, there you go. So it has move base. And we'll see. Yeah, looking at it. Okay, there is a TEB planner ROS. And there's, yeah, try that. So see, it's not even listed a local planner. So I think your local planner got replaced by TEB local planner. So now looking under here, you can find, look under, I just start digging through there and see if you can find what you're looking for.
Well, what's interesting is it's got some of these theta limits at 0.
Actually, I think the value is on the right hand side there, in the box on the right hand side. I don't know why it's. Oh,
It's a slider.
Yeah, the 0 there just says your lower limit is 0 and the upper limit is 1.0 on that, and then the actual value is in the box there on the right.
Even though, which is odd. So if I take, not that weight is a big thing. I don't know if it's including weight, but so maximum weight velocity X slider bar is not, no, maybe 2 is so small when 1,000 is the high thing that it is way down there.
Yeah,
Okay.
See if you move it. See if you move it.
You can probably also select it like that and use your right and left arrows to increase and decrease the values. Or yeah, you can just type it in. But now keep in mind,
So,
these
yeah.
values that say weight something, those probably have nothing to do with what you're doing right now, but it could be. Again, if you can find a tutorial that goes through and tells you what all these things are, this will give you a way to, you can actually play with these on the fly. If you change this, that is actually affecting your vehicle right now.
Huh. So let's
So click on the robot tab and see what either robot tab or trajectory tab. What do you have under there? There's the values that you're changing. So theoretically, at this point, you can change those anything you want and go run it again. In fact, while it's driving, you might even be able to change it while it's driving, but it may only load the parameters that starts the move. So, and the one down there says omnidirectional max velocity Y. Those are probably ignored completely, because when you set the thing that says the car-like parameters, so you go up a couple lines, it says car-like, it says minimum turning radius, wheelbase, and use the angle instead of rotational velocity. So none of those have to do with velocity, but once you set the car-like, the omnidirectional values I think are going to be ignored. So the one at the top there that says max val X, I would think is the value that is what you want. You might want to set your maximum accelerated limit X. I don't know, but anyway, you should be able to change those values and go, give it a new goal, and it should actually respond to those.
yeah,
So
like
rather than shutting it down and changing values, run it again. Once it's running now, you can go into that reconfigure and you can just change those without having to restart everything.
But how do you know whether it's going off the TEB planner or the global? Because I noticed that you've got the global planner right above it.
Well, because the global planner is something totally different. That just simply says, I'm here and I want to be at this other place on my property. And it just simply draws a line. It's creating if you look at his screen while it's running, that's the pink line that's showing up. And then the green line is the actual.
Okay.
See, it's got that little green line sticking out front. That's what he's actually controlling, is the values going to that. And the pink line simply says, I was at this point, I want to go to that point. So it just generates that line. So it's really has nothing to do with velocities. So the actual movement is controlled in your local planner. In this case, he's got the TEB local planner that's doing it. We'll see as he did that, see the pink line says, okay, I want to go from here over to there. And that just generates a path that it wants it to follow. So now the little green line, that little feeler sticking out, that's where it's trying to drive and trying to get on that path and stay there. So I think the actual movement, I think, is all going to be controlled in the TEB local planner parameters.
On that previous screen, did I see where it showed TEB global, TEB local? Does it have the parameters or not?
That's just showing you the TEB global is the purple
Okay.
and local is the green.
So as far as what it's showing you, I believe when you pull up that dynamic reconfigure, it's pulling the current parameters and displaying them, and then let you change those. So I think, yeah, click on that. And what was
It's
that?
like
Was
you have
that?
to release the previous one. Come on.
That might just be running slow. So, and you probably do have a reload button somewhere that, you know, things don't look like they're working right. There's probably, yeah, refresh. Just click on that. And what's that do? Anything? And I think it just reads whatever the current values are and displays them again. So
what if you change your max velocity X to, let's say, 10? We would expect to see a difference, correct?
there's probably a maximum limit he's got set on his vehicle. And since he's using the simulator, I probably put a maximum number on there. And that might be part of the problem, that you're just putting in numbers too big, but I don't know why it should bounce back and forth between speeds. But really hasn't changed. Can you display your command velocity again so we can watch it? So it's moving pretty darn slow no matter what you do. You could try picking a number, say like 0.5 meters per second, and see if that then, since this number is bouncing around between 0 and I've seen as high as 0.5, there's a 0.71. So pick a number that's smaller than whatever the maximum might be. So go back to your reconfigure and put in something like 0.5 meters per second.
What's crazy is I see negative numbers here at times.
Yeah, so it almost sounds like it's, you know, as it's planning, it doesn't think, you know, kind of like PID values. It just thinks it's going too fast or too slow or whatever. Aha. Aha. Now it's running the speed that you're telling it. So that gives you a clue as to something that might be acting weird. So you can go back to reconfigure and put in 1.0 and see if it responds to that.
Yeah, it's bouncing all over the place.
So it's either the fact that it's taking your forward velocity or your forward speed that you specify and your rotational speed, and for some reason when it does its calculations, it doesn't like the numbers coming out of that for some reason. So it could be, you know, if you got like 3 or 4 different numbers on that. So I would say, yeah, set that to some value, and then maybe next time set your maximum velocity X backwards to some other number and see if that makes a difference.
Say that in another way, set it backwards.
Well, right there on the screen, you can see it says max velocity X backwards is set to 1.0 meters per second. Maybe try changing that to 0.5 or 0.2 or something, and see if that affects anything else. Now, theoretically, it shouldn't affect anything because you're not, right now you are backing up, so it might affect it right now. But once it starts driving straight forward again, then, you know, just play with the values. There was probably like a theta value. You know, maybe play with that. It simply doesn't think it thinks you're turning too sharp or not sharp enough or something, and that might be affecting your forward speed.
Interesting that it gives it the 0.6 and it stays there.
But it stayed there for a while, but no, it's still jumping around somewhat. And don't be fooled. I think you've got two numbers set to 0.6 right now. So don't keep relying on one thinking that's what you're controlling when you're actually doing the wrong one. If you go back to your reconfigure again, so we can see what numbers you put in there. Well, actually one's 0.6 and one's 0.5. So the other thing I'm thinking of is this max velocity theta. I believe what that says is that's how sharply you're going to let the thing turn. That's controlling, you know, how quickly it can turn. And I'm not sure exactly what that's doing. It could be that max velocity theta. And it could be that number just simply is, I don't know if you want that a small number or a big number. And then the other one, what was the other one there? It was something about acceleration limit. Now that one, I think
Acceleration limit.
I think if you put a really big number in acceleration limit, that just simply will give you an instantaneous. So it's going to go from, if you tell it to drive forward, it's going to go from 0 to whatever your maximum velocity is instantaneously if you put a big number in there. Otherwise, you can back that off to say 0.1 meters per second. So each second it's going to accelerate by 0.1 meter. And that answers Terry's question. He was asking one time, does ROS control the acceleration deceleration for you or not? Well, that's what that number is doing right there. I think that acceleration limit X. And acceleration limit theta is, again, how quickly it can turn. I think there was two of that said something about theta. So anyway, what we've shown is while it's running, you can pull up the dynamic reconfigure and change values on the fly. So I think if you go back to the various TEB tutorials and try to get a definition of what those different numbers are trying to do for you. But as you also found out under, I think it was called optimization, you got a bunch of other numbers there that I've never dealt with, period. So it could be that something funny is going on in those, that you're simply setting a situation where it's able to go, you know, it's created a situation it can't match. And that's why it keeps recalculating all the time.
Any thoughts on why it would be generating a linear Y value?
Those are extremely small numbers. So I think I'm going to say it's probably acceptable. It's just falling out of their calculations. And it could be one of those parameters you have set up that it could be you should set all your velocity Y, set all those. Do you have anything there? I don't see anything there specifying. Well, again, but that's an omnidirectional vehicle down there, which should be turned off right now because that checkbox that says under car-like, the checkbox says command angle instead of rotational velocity, says it's going to use the car-like parameters and it should ignore the omnidirectional parameters. So I don't think those are being used.
I like that lethal cost.
You know, but for the lawyers in the room. Come on. I'm clicking that and this is this HC planning. I'm not familiar with that language.
Yeah, I don't know what HC means. That's probably something about, you know, trying to stay on the path. which, any number one of these anything here could be screwing it up. And I just don't know enough about all these extra values to know what's happening there.
So this is under the optimization tab. There's some Y values. But that's weight.
And those are probably just whatever the defaults came in, because if you didn't specify those little parameters, it's going to load whatever the default is for this whole package.
Weight maximum velocity.
I'm gonna ask a dumb question, but what's under help? Does it by any chance explain? Oh, it's just an about. Never mind.
And that's
Yes.
actually the entire, this is just one plugin module for this entire thing that's running. So that isn't going to get you too far. Yeah, but there might be some other things. So it looks like just inside of this, there's two little icons. One of them looks like a disk icon, and the other one looks like a folder. It could be you could save all these values out and just load them back in at some point. Maybe that's what it's trying to tell you, but I don't know.
I'm hovering over it. I'm not getting
Click on it and see what it does.
load from file.
So I think the other one will say save to file. So if you go through and make a bunch of changes, you could say save it out and then come back tomorrow and say load that back in, whatever you'd modified. So then what you would do is you'd figure out what you changed and then go back to your actual configuration eventually and put in what you for permanent way forward, you would do that. And I'm not suggesting you save and restore stuff at this point. I just wanted to know what those were.
Yeah, I was just interested in saving it and seeing how many parameters it actually saves.
I think it will probably show you everything you were displaying there is what it's going to save. It saves the whole thing and pulls the whole thing back in, is my guess.
Yeah, it does every
There's
tab.
lots of stuff there. So basically whatever's on the parameter server right now for the tab local planner, it loads all that stuff in and displays it for you. You can change any value you want, whether you originally specified it or not. Because again, the tab local planner has defaults for all these. Looks like hundreds of parameters here. And if you want, you can go to your parameter, in your launch file, say, change the velocity to this, and it will just overwrite the default for that. And you can tell which ones you're changing, because as I say, when you start up the launch file, at the very top, it says launching the launch file. Here's all the parameters that I think it only shows you the ones that you have changed. I don't think it shows you the default values. So that'll tell you which ones you are changing. And then when you pull up this program, it shows you everything, and you can change them all basically on the fly now at this point.
Well, I won't spend any, so this, where I was spending time on, this base local planner, that's not even appearing in this list.
I believe that's true. So I think when you say use tab local planner, it just replaces the base local planner.
Well, that's one layer of the onion to peel back. That's cool.
And if you just go to the ROS wiki and say, look under tab planner, it may or may not give you all the parameters there and a description of each one. It may just say, go look at the GitHub instead, and then they might have a better documentation of what each one of these fields is supposed to be doing.
That's good suggestions, Jeff. Thank you.
And while you got this screen up, it says trajectory. Well, it's doing various things in the code to say, you know, I'm here, I need to go there. It's trying to figure out how to stay on the line. And so any one of these numbers in here could be affecting it. But since they're all the defaults, I'm going to guess that in general, you wouldn't have to change these. I've seen people run this and not go through all kinds of weird modifications to get it to work. So I don't know what under HC planning, I don't know what HC stands for. That's kind of an odd one to me, I guess. So goal tolerance tab, I think that just simply says that's how close you have to get to the final goal before it declares that it's reached that. I think that's what that one's doing. And under obstacles, that's probably going to specify how close you get to an obstacle and then whether it needs to go around it or not. And since you shouldn't be seeing any obstacles right now, I don't think this will be of any effect, but again, I'm not sure.
Trying to go one path, one dot to another with no obstacles in front of it. So I'm just curious about it's getting so many calculations of the speed. I find that odd. It's recalculating the speed target. You know, I was going to do a ROS topic echo on how do you find the frequency at which command velocity is being
you'd say ROS topic hertz.
So if I give it a goal over there.
So instead of echo, put HZ.
I mean, I just find it curious that it's publishing a new command velocity. Well, it's backing up, so I get it. But on this long straightaway, let's see, can I do this dot linear dot X? Can I do that?
I don't know. For frequency, that's just part of it. So I think the finest granularity you'll get is the command velocity, I think. Now, if you wanted to say echo, you know, ROS topic echo, you might be able to say command velocity dot linear dot X, but I think it's going to be, it's already showing you that anyway. So I don't think that's going to help.
Yeah, I was just curious about why would it set the speed so many different times? It's just a curiosity more than anything in the process of trying to debug what's going on.
So you would probably have to look at something, you know, like there's going to be some other thing internally that the TEB planner is going to be publishing that might tell you those kind of things, but I don't know what those are. So
Let's see, at this point, it's mm, 5 hertz.
why was that saying no new message? That was kind of odd, but and it could be that by controlling that loop rate, that might be you make that faster or slower. It's saying it's doing it 5 times a second right now. It could be that you can either slow that down or speed it up, and that's going to be a parameter somewhere in the TEB planner. I don't know what it's called, but
the long straightaway, it will stick to the 0.6. At some point that freaks out.
Yes.
Not at 0.7.
And I'm guessing after you type that number, and if you just hit enter, I think that will do. I don't think you have to do a refresh each time. But in fact, try it right now. Just put a 0.9, hit enter. Well, you okay?
Freaked out.
Well, it's close. It was close to 0.9, but it wasn't.
Now it must be turning around or something, or it's getting close.
Do you have room to go all the way around your house? If you do, you could just keep specifying forward points. It won't back up like this. So at this point, you could go into your reverse velocity, put a big number there and see if it'll back up faster. Maybe it, I know you back that off to like 0.5 meter per second or something right now. So it could be if you put that back up to a higher number, it would turn around faster.
Yeah, I wouldn't do it physically, but I could probably squeeze through there.
You could go all the way around the house. You go all the way around that black thing that's over there. Just someplace. So basically, if you're driving in a circle, then you'll be going forward the whole time.
Can you put waypoints?
I would say no at this point.
Not as a 2D nav goal in RViz. You have to programmatically figure out waypoints. So I've got 0.78 there, even though. Let's go back to 8.
Yeah, before you go to the thing, put the 8 and then did you hit the enter key after you typed in 0.8?
I did.
Okay. Otherwise, just switch into another field probably updates it too.
That's interesting. Previously, we could get it to go up to 0.8. I just hit enter. Well,
I would go to that field that says acceleration limit X and change that to something other. It can go all the way up to 100. So I don't want to set that like 10 or something. Just see what that does.
hey, it's right on 7.
Now try 8.
Make sure I hit enter.
That's pretty close to 8.
Yeah, but it's still changing. 10's good. 15 must be better. That's point. Let's go back and see where we're at here. I want straight goals.
So I would bump up your forward speed again. Get it set at 8. Just make it, I don't know, make it 1 and see what it does.
No refresh, just enter. That increased it. Well, that. Just gonna let it get by this.
So pull up your command velocity again. So I was wondering if you can look at the angular Z down there. I was wondering if you can tell by that. You know, if it's driving along at point 0.9 or 1 or whatever it's driving at, and then if it slows down, see if the Z said it was trying to turn. It could be it decides if it's trying to turn, it's going to slow down. So there might be some interaction between those.
That would make sense. So if I give it. Oh, I don't want to do that. That's a good tip. Just choose the corners.
And I can't think of anything else that would limit your forward speed. But on the vehicle itself, I've probably got things in there that says, you know, set the maximum speed to 1 meter per second or 2 meters per second or something. But command velocity coming out of the tab planner, you know, that is the calculated value it's telling you to go. So it you know, I don't think it has anything to do with the actual simulation or the vehicle itself. It is just the tab planner, for whatever reason, doesn't want to go at those speeds.
Definitely a correlation between angular Z and it definitely slows down whenever angular Z.
Then go back into your parameters and try and change that. There's a couple, at least one more that says angular limit theta is a 0.1. Set that to like 10 or something. That's running really slow now, isn't it?
Well, watch angular Z. It's bouncing all over the place.
But you're only moving like half. No, at least once it jumped up to 0.9 meters per second, but it was running really slow otherwise.
See how far off a course it is?
Yeah, in fact, it's even turning to the left there for some reason. So apparently, so maybe put it back to the 0.1 or whatever, some other small number, and see if that. I think it was 0.1 to start with. I don't remember now.
It was.
So it's driving better now. But it is still trying to drive off the path for some reason. I'm not sure why. It could be even we got some weird numbers in there that either your wheelbase is wrong or there's various things that could, you know, it says do this and once it gets there, it says, well, that's not what I told you to do. So it's trying to oscillate back and forth to stay on the line because it should drive straighter than that to stay on the line, I would think. And the point of that is, you know, I'm saying, well, we're looking at command velocity coming out of tab planner. So that's what it wants to do. Well, the tab planner says drive straight, but for some reason the vehicle doesn't, it's going to drive off the line and the tab planner is going to say, oh, we're not in the right spot. So it's going to do something to try to drive back on the line. So even though I'm saying that we're looking at command velocity, it's looking to see where the vehicle actually is. If it's not in the right spot, then it's going to do all these things to correct for these things.
And instead of turning this way and coming straight, it's choosing to go this way and back up.
Can't you just grab your screen and drag it right and left to move it around? I know you keep clicking on something that says focus or something.
If I left click, I get rotation of the map.
Try a right click and drag. What's that do? Or is that zoom?
Right
Zoom.
click, zoom. If I right click and move up and down, it zooms. If I try to move left and right, it doesn't.
What about center click and drag? What's that do?
Bear with me a second. Scroll bar or scroll.
Yeah.
Yeah, I think scroll button is what you're. Yeah.
It just seemed like you're going through extra steps there to move it around. I wasn't sure what you're doing.
Going through extra steps. Because I was uneducated.
So if you zoom in on your vehicle right now, is it following the line fairly closely, or is it still wandering back and forth a lot?
It looks like it's following it.
And the speed was coming out like 0.93 or something. I don't know if it's,
Yeah, 9.5.
and I think you told it 1.0. So that's working well there. Now the question is why. The other thing was you were driving vertically as opposed to horizontally before, and it could be that it wasn't like straight. Right now you're going pretty much straight east, as opposed to before. I think you're going at some angle as you're driving north. So just little things, little clues
Hey.
like that.
Look at that. See, but angular Z is as long as that's small, then we get close to
And as you keep increasing, as I say, I think I put a limit in the code that says probably 2 meters per second is the maximum velocity I told it to allow, because I didn't want people doing things crazy here. So yeah, as you increase those numbers, you may not get, as you increase the number, the command velocity might be telling it to go faster, but the vehicle won't actually do it.
and when you say code,
In the simulation code, there's a program that's written in Python that's saying take the Ackermann message and convert it to wheel speeds. And somewhere in there, I just blatantly said if the incoming mod command velocity Ackermann controller pi is what it's going to be in there. And it's going to say read up the Ackermann command. Maybe just search for limit. I probably put a comment that said limit the speed to forward speed to something. Limit steering velocity, compute the vehicle speed, acceleration limit. Oh, I don't remember right offhand what that's called. So, but somewhere you're going to get a call back for Ackermann command, and then another ask you to say read in the values and store them somewhere. But that looked very suspicious. If you go back, it said something about 5.2 or 0.52. It was doing a bunch of checks on something.
.2. I'm not seeing that.
As you're doing searching, there was a block of code that showed up that said it was checking. It says, is it greater than or less than this number? And if so, set it to something. So I don't know. search for sub. Actually, maybe go all the way to the bottom and find find a word subscribing to messages. So controllers, Ackermann controller. So scroll up a little bit. Create command pub. It's creating publishers. Right at the bottom where the bottom function says get steer angle. Is there one that says get steer speed? Because that's one that
Get link position. No heavens, there's get steer angle. I'm going fast because I'm looking for speed.
The need for speed.
Yeah. I just want the need for understanding understanding the speed, get link position, get steer angle. We're almost to the bottom, my man. Get steer angle again. That's it. No get speed.
did we try to search for sub?
No, not yet.
So right there. So it says ROS subscriber, get the command. And so it's going to say Ackermann command CB. You don't want the self part. Just grab the Ackermann command CB. That's what you want to search for. Well, no, you want the one down below that says Ackermann command CB. That says that's the callback for that. Can you just search for that in this file?
Yep. I'm sorry to put it in the search bar.
Yeah.
Dag nabbit. But I had it. See. 2 spots. Yeah.
Okay, there's that 5.5.2 I was talking about down below there. So that's, you're in the right area. This is when you receive the command, the Ackermann command that says, here's what you want to do. And then somewhere there, I think I've got a limit set on the speed. So down below it says self speed equals Ackermann command speed. And I don't see anything that modified that up to that point. So if we just search for underbar speed, I think it will.
Times delta T.
This is the odometry type stuff, I think here.
Can I move on?
Yeah. Those things where it says defining down there. Do I have one that says something about maximum speed? I don't see anything. Anyway, that somewhere in the code, I did set an artificial limit saying don't drive faster than a certain amount. And I don't, it's probably in this program is where it's doing that. And I don't know what that number's set to. I don't remember if I made it a parameter or just, I probably just hard coded it in here somewhere. But at the time I picked something that I thought was reasonable, probably 2 meters per second is what I put in.
Well, we got it up to 1.4. And we're getting close to the physical. I wouldn't want it driving much faster than that. Or I wouldn't want it driving 1.9.
And that was my reasoning when I did it. So
Let's see that angular Z. Whenever that bumps up, the speed goes to nothing.
is it still turning around? Is that why it's acting like that? And as a side note, I just got an email here saying my package is delivered. So I should have an RC server out on my front step.
Playtime for Jeff.
In fact, while you're playing with it, I'll go grab my package and see.
Yes, that angular, if it comes off the line, speed goes to nothing. It even backs up there to get back on the line. Hmm.
That's interesting.
Yeah, so the question is, why does it think it's off the line, or why is it coming off the line? I think that's back to Jeff thinking we might have the dimensions wrong somewhere.
And it might think it's too close to that wall right there, which is why it's trying to curve away from it. But I think it still comes back to the point. Yeah, you're gonna have to go through all the parameters and see what they're supposed to be doing, and see if they tell you anything under the tuning, what you can do to make it work.
Yeah, see how it's why would it be doing that? So the function of repackages a modified command velocity into an Ackermann command message and publishes it. So it's not doing any planning.
Actually, you could open another window and publish your Ackermann command at the same time, just to make sure it didn't do something stupid in the translation process. Because the tab planner puts out the modified command velocity, and then I wrote this program that just takes that and repackages that as an Ackermann message, because that's what the other program wants to see, as an Ackermann message. It's just going to be, it should be the same numbers, just stuck in different fields is what you should be seeing there.
Well, guys, I've got a 1 o'clock appointment that I need to get ready for, so I'm going to call it a day. But thank you. Yeah, how to leave. Okay. I look forward to watching the rest of what you do once you have it posted.
Good deal. Thanks, Terry.
Thanks.
This Ackermann command, Jeff?
Yes. And if you can display that at the same time, you're also doing the command velocity, then you can compare the two. So just open a new window and echo that one.
Ah. Ah.
So that I believe the steering angle on the Ackermann should match the angular Z from the command velocity. And then the speed should match the angular or the linear X. And since they're in different orders, it's going to be hard to tell, but steering angle velocity is always 0. So I think I just grabbed the two values and stuck in there. And as long as those seem to be matching, then I'm going to say then that program is probably working. And it looks like it just in general looks like they are tracking each other.
They seem to be matching. What's, I think, worth sort of.
But it comes back to the fact the planner doesn't like something, and it's keeps trying to drive off the line or trying to thinks it needs to drive onto the line for whatever reason.
Yeah. Because it should be a piece of cake to drive that line.
I would think so. So again, it could be that it's, as you're driving past that, you might notice that as you drive. See, right now it's acting funny when it's next to that big black thing. So when it gets out into the open, is it going to, as it gets past this big black thing, will it then try to turn to the right because it sees a thing on the left, or is it, or does it drive straight until it gets to that square black thing and then try to drive away from that? That'll tell you if it's the obstacle detection or not. And it could be you can turn on things like your cost maps and see the inflation layers, and it might show you that it's trying to drive through something where it shouldn't. That's really quite unhappy in that area right there. When it was driving along at the top of your house, it seemed to be driving quite straight there. And I don't recall, we could go back and watch the video to see what you're doing, but so once it got straightened out there, it started driving fairly quickly forward. So now as you're getting towards that black thing there.
Yeah, it gives it the gas and then it goes off the course and then it says, oh, I went off the course, I better correct.
And that's kind of why I'm thinking there, something may not be correct there. Either like wheelbase or whatever. Now it doesn't seem to be hesitating going past that black object. So I don't know. We'll see. Now we'll see. Here's out in the open again. So we'll see if it straightens out and drives fast until it gets close to something.
Yeah, that's not.
So it seems to be doing a fairly good job now that it's out in the open, but I don't know if it was being affected by things or not. This would be a good time to pick a new destination so it doesn't try to back up when it gets to the corner.
It won't go forward.
Which I was thinking pick us up a little closer to
Oh,
2 or 3 points to make it go around the corner without backing up. But this will be interesting. It'd be going at a not a straight vertical line now. It's going to be going off to the left, and see if that makes any difference. And it could even be that when you translated it to your lawn tractor, that some of the parameters aren't the same. Maybe if you select my tractor that I created, which I had spent more time on trying to figure out all the numbers, it would run better. So it may be something, either your wheel diameters or your, something funny about that may have screwed up something in the tab planner. So it's having a real hard time now trying to stay on that, since it's not a straight vertical line. So when you were just driving horizontally to the left, that was almost, like a 90-degree type line. It seemed to stay on that, but now it's confused trying to stay on this. So it might be tab planner parameters, it might be obstacle detection, or it might just be that the values that are put in to represent your tractor here, something got missed as it's, as you did that.
yeah, I can go back and look at the,
There's a lot of numbers buried in there. It might be hard to, figure out what all of them is supposed to be. So
well, there appears to be 3 Zacro files. I mean, this.
and then somewhere there's also parameter files that go along with this stuff that have to match. And I don't remember where those are stored. Those are, maybe go up to Ackermann vehicle, and then look in there. Is there look under config? Well, that's apparently not where it's at.
What sort of parameter are you looking for?
Under the simulator stuff, there's just 2 parameter files that get included in with they're either called parameter files or config files. I don't remember. That in fact, that might be them right there. And since those aren't specific to one vehicle size or the other, it could be there's something in there that needs to be changed and didn't get changed.
So I didn't I obviously included these so that it would run, but I didn't.
And I don't see,
change-
I don't see anything in this file that, because the rest of it's commented out, right? So maybe the other file, one of them said something that had like things like wheelbase and some other numbers in there that may have to be changed as you switch from one vehicle to another. And keep in mind, this wasn't fully debugged when you got it and started playing with it. So
No, I know. I'm happy to have it.
look under config again and look at the other file that we just like. There's two of them called. Yeah, go into there. And there's is that the
This-
one? But look at one and then look at the other and see.
This is the second one.
Okay, so there it has actual wheel diameters and so forth, and it looks like those are probably the 0.356 is probably the 0.48 diameter. That's probably the numbers for your vehicle, and the ones that are commented out were probably the ones for my vehicle. So if that's the only thing in here that's changed, is there anything down below that? So it's wheels.
The stock shock absorber, but it's all commented out.
Yeah, throughout the shock absorbers. So it looks like, no, it looks like you probably have the right numbers on this config file. So maybe in the URDF file, there is something that, 'cause at least at one point when you're trying to get the height of your thing set correctly, I realized, oh, there's things in there that didn't get all that changed. So
So the launch file, I think this, forgotten exactly how this fits together. There's three of these that it uses. This was the one that I think I changed in order to get the wheels. They were under the ground level.
at this point, I would say if it's not too much trouble, because I don't remember how this all went together, but if you can switch it back to my SAMI URDF and see if it runs, and then see if it runs any better than the one you've got, that would give a clue as whether it's something about the size of the vehicle that we didn't get everything changed or something. That might tell you if you know where at least the problem might be.
Yeah, I can do that. I think it's just a couple of
It's probably just in the launch file. You just say point to my YAML file as opposed to your YAML file, but I don't know.
oh, let's see.
Right there in the middle of the screen, it says base local planner, value tab local planner, and then under that it says controller frequency and controller patience. That's probably that 5 right there. You saw it was publishing at 5 times a second. You might want to play with that and see what it does.
You think less frequently?
I don't know. I don't know what it's going to do. But as I say, it's just something else you can play with. And the controller patience, I'm not sure what that is. If that's maybe something about if you're too far off the line, I don't know what that patience one is, but the controller frequency might be. That's something else you could play with. Now keep in
And
mind,
it's got-
that's the global planner. You're not worried about the global planner.
Is this the green line and this the pink line?
The top one's the pink line and the bottom one's the green line. So TEB local planner is the green line.
Okay.
So I was saying before, maybe changing how fast it runs might make a difference. And this is where it's located. I just wanted to say that.
Okay. I thought,
I would think it would be in this one. Let's see. Ackermann vehicle.
that's the file I was talking. That's the one that calls 3 different.
Yeah, so that's probably the one where it would specify which vehicle to run.
Yeah. See, this is the. I'll just change-
The one that says Sammy sensors. I thought, well, you had multiple vehicles, but no, you don't. You have if you change that, the one that says Cub Cadet Param Zacro, if you change that. Oh, in fact, right above it says there's the file right there that's commented out where it says Sammy Param Zacro. So uncomment that line and comment out your Cub Cadet line and see if it comes up and runs.
let's see. Use Sublime. No, I must have just copied it. It's not liking that. Why isn't it liking that? Why
Oh,
isn't it?
go to the end of line 4. You deleted the closed comment off that one. So go to the end and put dash greater than, and that'll fix it. There. I was talking to you and realized I was on mute. So I saw what you did, but I wasn't quick enough.
Thank you. Oh, let's see. I don't think there's a.
And the fact that it's got a lot of warnings and stuff on here, that might give you a clue too, that thing is running. So when you get it running again, you could, while it's running, while it's doing wild things, trying to get back on the line, see if it's giving you errors during that. So that might give you some more information too. And since you didn't shut everything down, at the bare minimum, you'll probably have to do a refresh on the reconfigure program.
That look like Sammy?
Yes, it does.
Usually I get a message about ODOM received here.
Do you have the TEB planner running now?
Yes, that's what was started. So I'm not sure if this is gonna fire up or not. Yeah, it gave it a plan. Hmm.
Is the vehicle driving straight yet? Or is it still backing up? Kind of zoom in on it and see how well it's tracking the line. Is it running at whatever speed it's supposed to?
Well, it's running at 0.4.
So here you may have refresh might fix this, or you might have to shut this down and restart it, like you were doing your other echo commands.
Well, let's just shut it down and restart it just so we can know for sure.
So right at the moment, it looks like Sammy's going fairly straight down that line. Oh, there it just did something wild.
Yeah, if you watch that Z, it's working hard at staying on the line.
Yeah. And I just saw that ODOM received message as you're flipping screens there, so it did finally come up.
Get rid of that. I think we back to RQT. Has 1.8 up there.
And what's command velocity say right now?
.38.
So now part of it is, you changed various things on that RQT configure. It could be, you could go back and say, if you saved it, then do a reload and get back closer to where we were. Otherwise, you're gonna have to go back and watch the video and see what we changed and what made it work. So
You're right. We
'cause
changed.
we changed a bunch of that stuff, and I don't remember what we changed it to. So you're back to the point where you can play with that and see if this vehicle works any different than the one you've got. And I don't know if that's really gonna, answer all your questions, but
It's working hard at staying on the staying on course. Where did I put that? I thought I would have put it in config. Now I know I put that in. It's called Thursday testing. Wonder why it's not showing up. I think it's actually. Yeah, right there, config, there's testing. Still there. Wonder why it's not finding it.
maybe it doesn't.
Okay, Jeff.
Maybe it doesn't like the extension is why it can't find it. But anyway, you got lots of stuff to look at now.
With a very straightforward problem. Why isn't it steering better? Oh, goodness gracious. Part of me wonders if I have a Dubin's path planned with pre-existing waypoints, if I get the same behavior, whatever that's going to be TEB planner that reads that. I'm just thinking out loud here. That generates it.
I don't think there's any point moving on to something else until you figure out, until you get it to drive like it's supposed to. There's no sense adding more layers on top of this.
Does this use TEB planner?
Well, it uses move base flex, and move base flex may or may not have the TEB planner loaded. I think probably the time you're running it did. So yes, it would use the TEB planner. So you do have the option here of swapping out move base for move base flex and go ahead and leave the TEB planner loaded into that and see if you can get that to run again. I don't remember why it wasn't working, because you're not using move base flex at this point, are you?
No, it's plain Jane move base.
And if you go back and look at your code when you were using move base flex, it could be, it's copying a few lines into your launch file will allow you to run that again. If you really want to go down that path.
Well, I'm thinking, and you've clarified that TEB planner, even if I've got a series of waypoints here and they're being fed to move base. Temp planner is still generating the command velocity statements to get it there.
Yes, I believe that's true.
Yeah, see how that's just taken off to the left?
It's doing a really horrendous job at trying to drive. Yeah.
Oh, but I got to go back and watch the video and see which ones we've changed. It got it steering a little bit better. It was around that. We trying to get back to the, maybe it's not going to let me if I've got that open. We changed these thetas and limits. I think that was 0.1.
And under wheelbase there, it says 1.219. I don't know if that's my wheelbase or your wheelbase. You recall the, but that's got to be your wheelbase that's put in there. So that's going to be another issue. And I don't remember where that stuff got defined. So, you know, switching between the two tractors, there are multiple places you have to change things. So that might be yet another problem.
I'm wondering, do I even know your wheelbase?
It says 0.505 there. I assume it's somehow it got the wheelbase for your vehicle. Now it might be in one of those parameter files in addition to the URDF. So I don't know. The one parameter file that was defining the wheel diameters should have also had the wheelbase in that one, I think. But I don't recall. No, you're using that same parameter file.
In the SAMI parameter?
In the robot URDF Zacro, I think is where you found that. No, that's not what it was. It was right there. Stay on that page. The SAMI sensors. So Cub Cadet Param Zacro. No,
Remember, that's
no,
the one we commented out.
no, this was the it's under your config directory.
Say that one more time.
It's under your config directory, not under your URDF directory. And then you got those two EM 3905s. One of those has something about wheel diameters. I think it'll also have the wheelbase in there.
So we're in this one.
Okay, so it says left front wheel, right front wheel, left rear. I don't see wheelbase listed there, so it's either in that other parameter file or it's got to be possibly in the Zacro file. Now it could be, since you didn't shut everything down completely, you still got some extra stuff just kind of hanging around. You know, if you'd shut ROS down completely, you know, all command lines are killed and then start it up again the way it is right now, that might have parameters left over from last time.
Okay.
So that might be one of the first things you want to try is, you know, try that and see if that fixes the, you got the thing, you can go look at that wheelbase and see if that change, because you know that was the problem right now. We saw the wrong wheelbase in there. So I'd say shut everything down, start it back up, and then go check that again to see if the wheelbase says 0.505, it says 1.2.
Roger that. So I'm just going to write it down so I don't. That old school. Yeah, SAMI wheelbase is 0.505.
Yes.
And do you have any recollection of the wheel size?
No, but it's in the previous file you just had open. Just go over one tab to the left there. It's in there. So that my front wheels are 0.25 and the back wheels are 0.305. Oh, in fact, right there, see this file should have my numbers, not your numbers in there. So that's an issue right there. So swap those instead of 0.356 for your front wheel, make that the 0.25. So this is one of the things where this didn't get carried through. This doesn't automatically change. So
is it possible to use a name of a parameter in this file?
I don't know. This is not used in the same place. This is used by a Python script, reads these up, and I don't know what it would take to do that. There
Okay.
may be some way to do it, but you know, as I said, there's a lot of things that could have been done, and this is how far I got it. And I realized there was an issue in trying to get this stuff to work, but
And the name EM 3905, is that special to you, or if I change this to SAMI parameters and Cub Cadet parameters, any issue for you?
no, other than whatever's calling it has to know the name, I guess.
Right. I'll go find out where it's called from.
And that would be under the launch file when starting out the gazebo stuff. Somewhere in there, it's going to say, you know, load these parameter files is where that's going to be.
That just goes to robot. And that's the gazebo. Ackermann's Acro. I'll find it.
It should be in this directory, I think. Or what? Right at the very bottom there is where it's at.
There you go.
There's two lines there. There's one there and one line below that. So, and I think we decided the one file doesn't have to change, but the other one's got the wheel diameters in it. So that one you could change that to, you know, change it to whatever you want. I think it's just the name here and then the name on the file is all it's going to take to do that.
Yeah, I'll just change them. So it's a SAMI set and a Cub Cadet set.
Okay.
Well, thanks for your time. Although we got it running a little bit smoothly, I think I'll go back and watch the video once you've published it to see exactly what we changed.
So here's my new servo that just showed up.
Oh, that's fun.
And here's it comes with this thing, which is normally another $10 to $13 for that. So, and then it does have the extra thing here. For some reason, there's a jumper block, but I think one side says ground and the other side says voltage output. So I don't know why they'd short those together. It seems like you wouldn't want to do that, but I'll look into that and see what I can figure out there. So, but this one, see, does have the pot is on top of the board. And it's got 3 wires on one side, and on this side it's got the single wire, and that's one where normally I'd solder a wire on to get the feedback. But if it's just connected to this thing here, I don't have to solder anything on. I can just plug wires onto it and go with that. So, and it does look a little bit different. The case, let's see, I don't know why they're different, but it's just seems it's got it looks like they made a special case for it, or ordered a different one or whatever. And then from the top, they pretty much look the same, but there's, you know, slight differences to it. So I'll just have to hook it up and try it, see what it does, and just experiment. And I don't know if the motor.
You've got on the one with your left hand, you've got some screw terminals there too that aren't. I don't think we're on the one in your right hand.
Well, I don't know which is right and left here, but let's see.
The blue board has screw terminals on it. Oh yeah, I guess the red board does.
Here, let me talk so it switches back to me. So I think they've No, I think they're pretty much the same. It's got the green screw terminals you're talking about.
Yeah,
Well, the other one has blue screw terminals, but they're
Got it.
still the same. So I think they're, they're pretty much the same. The number of jumper pins where you got shorting blocks and you can plug wires into it are arranged a little bit differently, and I'll have to look into that to see. I think I found a PDF somewhere that tells me what those are. So I'll have to look at that and see what I can make it do. And I think the motors are the same size motor, but I don't know exactly. Sometimes they're labeled. Oh, here's the part number on the new one. It says ASMC-04B. And then it says 180 kilogram per centimeter robot servo. And that's what it says on the back there, but you probably can't read it. Do you know these little, how the focus works on these little web cameras? It's one of those Logitech high definition cameras. Does it have a motor in there, or does it somehow through software, is it monkeying with the image?
I'm assuming it's all software.
Because that just baffles me how that works. And so anyway, I got that, and then I got the package of. I'm surprised how small this is. It's just, these are the optoisolators. It's a little 4-pin dip parts, and theoretically they're supposed to be. I thought it said 50.
Hold it closer, see if it'll focus on the part number.
Well, let me see if I can focus on the part number. It seems like a lot of it is you got to hold it really still to get it to focus on anything.
Yeah, no dice. It's
But
just
it's not, it doesn't want to work. So it certainly doesn't look like 50 in here. So maybe it's 20. I have to go back and look, see what I actually ordered. Well, there it says, I don't have a magnifier handy here. It might say 20 pieces. Maybe it's 20 pieces for $6 or whatever, or $8, whatever I paid for it. So that's something else I can play with those. Other than that, I guess that's all we got for today. We spent a lot of time here, so hopefully we're closer to where we want to be.
I think we're getting down to it.